Hi, we're Team 10, and we are the neck proprioception team. We're working with Dr. Hirschberg in the reactive lab, and the patients that we're working with are patients with neurological disorders and neck pain. So we'll be monitoring their neck pain by having them wear a hard hat with 2 lasers. We'll be using the LabVIEW program to measure their initial position and their final position. They'll be either moving up, down, left, right, or a combination of the directions. And we'll be measuring the error from their initial and final positions. So the users for our design are going to be the proprioception patients as well as the doctors that'll be diagnosing them. So our system consists of a hard hat with 2 lasers. We decided on red lasers because they're most easily picked up by the camera and our LabVIEW program. And the reason why we have 2 of them is to measure both the horizontal distance and the error in the tilt of the head. The hard hat is adjustable to fit a variety of sizes, and it's secure to make sure it doesn't wobble or add any extra noise or error in our experiment. In the procedure, we're going to make sure that the patient is sitting 50 inches away from the wall, 50 inches. And the patient is now 50 inches from the wall.
We will begin the session. Press start. No, I want to calibrate the camera now because I do not have a current calibration number. Make sure there's 2 lights on the wall that the camera will pick up. Calibrate now. Now I need to measure the distance between calibration points in centimeters.
The distance is 33 centimeters.
33. Okay. Now we have a calibration number of 10.97, and if we use this camera without moving again, we can enter that calibration instead of going over this calibration process. Now I'm going to enter the patient's name, Parham, in this video. If that was not correct or at any point you need to stop, you can click abort. But since we do have a solid calibration number, we will record a movement. So we chose left. Time for movement is usually 3 unless you designate a different movement under other. Usually 1 second is needed to get into position unless the patient is running this himself. And when he's ready, we can press begin. Are you ready?
Yes.
We are ready to begin. Close eyes now. Turn head to left. Return head to neutral position. This trial is over. This was a successful trial. He wasn't interrupted by anything. Comments. We're going to say first test or anything else you desire. Do you wish to run another trial? We are going to say no. But if we said yes, we would just go back and record another movement. So we do not wish to run another trial. We're going to save this as test A. Okay. When you open the VI, press start to begin session. You'll either calibrate or have an entered calibration number that will give you this value. The date will come up automatically. Then you need to enter the patient's name. If at any point you wish to end the session, you can press abort. Once you have set up your session, you can record a movement. Choose a direction, left, right, up, down, or other, a time for movement, usually 3 seconds, and a time needed to get into position. Then you can begin your trial. Follow the audio commands. At the end, a graph will pop up with the blue circle and the blue dot in the center of the circles showing where you initially started. The orange dot will be where you finally started. This trial we measured out as 7.5 centimeters to the southwest, which is good based on our data because between the yellow and red lines, we have 6.5 centimeters and 8.5. So 7.5 should be between these lines. As you can see here, this is a correct trial. Tests had a calibration number of 12.2, as we can see here. The date is automatically recorded along with the patient name that you entered. The first trial will tell you the direction that you chose along with the offset distance the offset angle, and the tilt difference between your initial and final frame. And this is the tilt of your final frame, and this is the tilt of your initial frame. This results showed that the final dot was outside the target. This was a validation result, so we measured 19 centimeters with the physical ruler, and our distance calculated was 18.3, which shows that our validation is correct and the distance that we measure is correct.
So this VI captures the image of the laser and converts it to an X and Y position. So when I run it here and use two lasers in front of the camera, as you can see, there are two circles detected. And then when we go to the log diagram, here we have this stuff captures the image, records the video, and then inside this loop we do the image processing, where it recognizes red circles and gives us the X and Y positions of the rightmost and the leftmost circles. That's it.